So yesterday we looked at our two other kind of examples, and then remember that I said that really one of our biggest growth and decay applications is population. And that can be either growth if our population is increasing, or it can be decay if the population is like dying off. So you'll see it in either one. This specific example, we're looking at the population of coyotes in an area. So it says the rate of change of the number of coyotes in a population is directly proportional to 650 minus n of t, where t is the time in years. T equals 0, the population is 300, and when t is 2, the population has increased to 500. Find the population when t is 3. So what's our goal here?
Population when time equals 3.
Correct. And so eventually we want to plug in 3 for t, but in order to do that, what do we need?
C and
K. Ish. We need an equation, right? So that's our starting spot. Which, if it is just like our normal population growth, that's our y equals CE to the KT. Okay? We do have to be careful here, because remember that in order for it to be our strict, like normal growth equation, okay, the rate of change has to be proportional to the original function, meaning that it has to be directly proportional, in this case, to n. The problem is that it's not directly proportional just to n. It's directly proportional to 650 minus n. So that means that this equation is actually going to look slightly different than just our like normal growth model. Now, we will still have to find a c and a k. However, we are going to have to solve it first before we can just write out our exponential model. So, remember that when I'm talking about a rate of change, what are we talking about? What? Derivative. So in this case, our y is technically n, so I'm going to have dn, and our x is t. So we have dn dt. That is our rate of change. And it is directly proportional, okay? In the past, it was directly proportional. It would have been like kn or ky, okay? But this time, it's directly proportional to 650 minus n of t. I'm going to go ahead and drop the t just because it's easier to have it just as n. But we understand, just like when we have a y, we understand that like y can have t's or x's in it, so can n. Okay, it's just taking the place of that. Which is why I said we're going to have to go ahead and solve this. So what's our only method really that we have to solve differential equations?
Separating.
Yep, separating our variables. So in this case, I'm going to separate my n's and my t's. We're going to go ahead and keep that whole 650 minus n together. So I'm just going to divide by that whole thing to both sides. And then we also need to multiply by a dt. So I'm going to end up with something very similar to our normal population growth model, but it is going to be slightly different because we have this 650. So how do we take the antiderivative of the left side?
Natural u sub.
Yes, so it is going to have to be a u sub. So my u is going to be 650 minus n. So what's our du?
-1.
Almost. Negative our negative over. So I am just going to end up with a natural log of the absolute value, but it's going to have an extra negative in front, okay? And it's just going to be of u, okay, because there's not anything else really going on. And remember, our u was 650 minus n. Then what's our antiderivative of k dt? Be careful because what is my variable that I'm taking the antiderivative with respect to? T, right? Do I have a t here? No. So k is not my variable. K is acting as a constant. Yes, so k is acting like a 2 or a 1/2, right? So I don't add exponents to k because k is a constant. What would we do instead?
Multiply by t.
Yeah, it's just going to be kt. And then I do have to have our plus c. So like I said, this is going to be very similar to what we did in the past. So I have a natural log. How do we undo natural logs?
Exponentiate.
Cool, but what does it have to be first? Correct. The natural log has to be by itself, and right now we have a negative. Yes? So we need to divide both sides by a negative. But this is going to be magic. Just watch. What is k?
A constant.
Cool. Can a constant be positive or negative?
Yeah.
What is c?
Constant.
Just a different constant, but still a constant. Can it be positive or negative? Yeah, so does that negative really matter if I divide it over to the other side? No. Now, we will possibly get positives or negatives when we plug our initial conditions back in, so we do have to be aware that we could get negative values there, but our values that we plug in are going to take care of that, so we really don't have to worry about it. So now, can we exponentiate? Yes. So if I exponentiate, I get the absolute value of 650 minus n equals e to the kt plus c. Are we all with me up until this point? Cool. What do we like to do with this plus c?
Bring it down.
Cool. So we would change it technically to like times e to the c, right? But then that just becomes another c. And again, c's can be positive or negative, which is why I'm also dropping my absolute values in that step as well. Yes, no, maybe. Okay, last step, I still need to solve for n. Because again, I'm trying to make a function or an equation where I can plug something in for t. Yes, that's my goal. Okay. So what do we need to do to solve for n?
Minus 650.
Okay. And then? Last step?
Multiply by -1.
Yep. Now again, c can be positive or negative, so I don't have to put a negative in front. However, negative 650 is a very specified constant, so I do have to flip that sign. So that does need to become plus 650. Alright, okay with that. So just be careful with your signs, because I can't just drop all the negatives because I feel like it, right? I can only do that when I also just have a constant there. Yes, so maybe. So now, like before, our goal is to solve for c and k. That way we can plug in our 3 for our t. Are y'all with me there? Alright, so I'm going to, what did we have? N equals c e to the kt, and I had a plus 650. Yes? Alright. Just giving myself somewhat room. So these do give us, just like before, two different things. We do need to be careful this time, because when t is 0, our population is 300. But that does not mean that c is 300 this time, because we have this extra plus 650. Does that make sense? So we do have to go ahead and plug in. So I'm plugging in 300 for n. If I plug in 0 for t, what's going to happen with my e to the stuff?
1.
Just 1. So then what is our c value?
Negative 350.
Yep. a 4 or 5 part free response question. Like first part A would just be to set up the differential equation and solve it. Part B would then be to solve for K and T, and then like part C would be to like actually plug in the T value. So now what do we need to plug in to solve for K? What else do they give us?
Different value of T.
Yeah, what is it? Specifically T is
2.
and N is 500. So I have negative 350 e to the 2k plus 650. So how do I get rid of an e to stuff?
Natural log.
Okay, but my e to the stuff has to be
By itself.
by itself. All right. So what would we need to do first?
Subtract 650.
Okay, and we get
150.
almost
Negative 150.
negative 150, and then we're going to
Divide by negative.
350. Can we reduce that?
Probably.
You can. Now, if it's gonna cause you like more brain power than necessary to reduce that, then don't. Just leave it like that, and you'll plug that into your calculator, and you would be fine. Okay. Now, if we notice, right, both of these negatives become positive, I can reduce my zeros. I then have 15 over 35. 5 goes into both of those, so I end up with a 3/7. Are we all okay with that?
Yeah.
Okay. Again, if you didn't reduce it and you left it like that, you would be fine. Either 1, if it was non-calculator active and you left it like that, that would still count because those are equivalent, or 2, if you then plugged it into your calculator, you'll get the same thing either way. So if the reducing bad things happen and you put 5/7 instead of 3/7, don't reduce it. But then to get rid of my e, what do I do?
Natural log.
Natural log, and we would also have to divide by a
2.
2. So that's going to be my k. It's no biggie. So finally, we can get to what we wanted to do all along.
Plug it in.
Plug it all in, fine. So we have n equals negative 350 e to the, I now have my k value, so 1/2 natural log of 3/7, and I want to multiply that by 3. Again, we kind of talked about this yesterday. Be careful because remember this 3, it is still in the exponent, but it is not inside my natural log. So make sure that you like in the parentheses for the 3/7, or even easier, move the 3 to the front. So make it like 3/2 times the natural log of 3/7. Also, remember this plus 650 is still there, so don't forget to add that. But then, if we plug all of that into our handy-dandy calculator, we should get some coyotes. What do we get? 551.802, and we are in coyotes. You could also go ahead and round that to 552 coyotes if you don't want like a part of a coyote. Okay. I mean, it's the majority of a coyote. It's 0.8. Okay. It got its tail cut off or something. I don't know. Now, like I said, the directions for this, I wrote it as one big thing because it's hard to put like parts on here. However, if this was like a free response question, right, this would be the prompt, right, just up to like in years, okay? Then part A would say like, solve the differential equation to find the model, right? And so then our answer for part A would have been just like this part, right, where we solved our differential to get that. Yes. Then like part B would say, then it would say this is true, okay? Find the specific solution, right? And that would be basically this without plugging in the 3, yes? And then part C would be like, after 3 years, what is the population, okay? And then that would be your final answer, okay? So it would be broken up a little bit, but just for rule, that's why I put it as one prompt. Questions, concerns, comments on? Yeah.
So you said that the signs don't really matter on like the constant.
On your constants, yes. So like, I'm thinking you're talking about on the previous page when I had a negative natural log and I divide. As long as both of my things are being multiplied by one of my constants, I'm okay to just drop the negative. Because basically you can kind of think of like the constant there sucking up my positive or negative. But we do have to be careful because like once I put this minus 650, right, this is no longer an arbitrary constant. This is a very specific constant. So when I divided by the negative on my n, I did have to account for that actually on my 650. Does that make sense? But yes, our like arbitrary C's and K's can suck up our negatives as needed, which is nice. But if it makes you feel better to put like minus KT minus C, you would get the same thing because you would add C, divide by a negative, and so you would end up with the same answers as you got before. As long as you're solving correctly and plugging stuff in correctly, you get the same thing. Other questions?